Hello everyone. We are a high school multivariable calculus class, and for our final project, we decided to make anamorphic sculptures based on at least two distinct perspectives. First, let's discuss what an anamorphic structure is. An anamorphic structure is a distorted projection requiring the viewer to occupy a vantage point. The structure is created when the image in the perspective plane is transferred onto a second plane. This means that they are 3D designs that look like different images based on which way you look at them. Matthew Robert Ortiz is a popular designer for anamorphic structures, and here is an example of an anamorphic structure from Matthew. As you can see, from the first vantage point there is an elephant, but as the vantage point changes, the image transforms into two giraffes. So how did we graph in 3 dimensions for this project? First, we graphed the structure in the xy plane. We then added the z value into the function to create the depth. Finally, we added a coordinate for the xz image to represent the second image. Here is a simple example. As you can see, in the first step, we are looking from the xy plane. Our goal was to create a circle. The second step was adding the depth, which you can see in the 3D view. Finally, we added the second image of our coil, which is through the xz view. Here's a video showing how the perspective changes. Now for a more complex example, breaking down one of the projects we made in class using the same procedure. Step 1, you can see, we use the xy plane. Then moving on to step 2, the 3D image. And finally, step 3, through the xz plane. And now here is a video of this project's transformation. So here's what our next group did. From one side, it looks like a flame. Another side, a DNA helix. And the final side, it looks like a flower. Now here's a video of this transformation. Finally, the last group made it look like a sword from the side and our school's emblem from the top. If you're interested, go to GeoGebra 3D and try our first example and explore. Good luck!